In this video, we're going to finish out the worksheet factoring trinomials where a is greater than 1, picking up where we left off with number 13. You can find this worksheet within the KutaSoftware website under the Algebra 1 section. It's also known as factoring quadrilateral polynomials hard, and that's because the a is greater than 1. In number 13, our a is 4, our b is negative 17, and c is 4. So we're going to multiply a to c, which is 4 times 4, and that's 16. Then we're going to see what factors of 16 will add to give us negative 17. So writing the factors of 16, 1, 16, and there's more, but I can stop here because negative 1 plus negative 16 equals negative 17, and negative 1 times negative 16 is a positive 16. So now I'm going to rewrite our original polynomial as 4n squared plus negative 1n plus negative 16n plus 4. So the value has not changed at all. I just split up that negative 17 into negative 1n plus negative 16n. Now I'm going to group the first two terms together and the last two terms together and pull out a greatest common factor in each. So n is my greatest common factor in the first one, so I'll get 4n minus 1, and then negative 4 will be my greatest common factor in the second grouping, so that I will get a positive 4n and minus 1 again. So I have 4n minus 1 times n plus 4n minus 1 times negative 4. So I'll write n minus 4, and n and negative 4 will both get multiplied to 4n minus 1. So n minus 4 times 4n minus 1 is my solution in number 13. In number 14, my a is 6, my b is 7, and my c is a negative 49. A times c is going to be 6 times negative 49, which is a negative 294. So the multiples of 294 are 1 and 294, 2 and 147, 3 and 98, 6 and 49, 7 and 42, and 14 and 21. So I have to find which two will add to give me a positive 7, so one of them is going to be negative. Looking at 14 and 21, if 21 is positive and 14 is negative, negative 14 plus 21 will give me a positive 7, and the multiplication of those two is a negative 294. So I'm going to write this as 6x squared plus negative 14x plus 21x, since negative 14x plus 21x is a positive 7x, and we're still subtracting that 49. Grouping the first two terms together and the last two terms together, I'll pull out a greatest common factor in each. So in the first one, we'll have 2x, and that'll leave us with 3x minus 7. And in the second grouping, I'll pull out a 7. That'll leave me with 3x minus 7. And if you want to double check, 2x times 3x is 6x squared, 2x times 7 is 14x, and that 7 subtracted, which is the same as adding a negative. 7 times 3x is 21x, and 7 times 7 is 49, and both of those are subtracted. Now I can factor out that common binomial 3x minus 7. So I have 3x minus 7, and that will get multiplied to 2x plus 7. 3x minus 7 times 2x plus 7 is the factoring of number 14. And number 15, a is 6, b is 37, and c is 6. A times c is 6 times 6, which is 36. The factors of 36 are 1 and 36, and there's more, but I can stop there since 1 plus 36 adds to give me 37, which is the b value that I'm looking for. So I'll rewrite 15 as 6x squared plus 1x plus 36x plus 6. Grouping first two terms together and the last two terms together. I'll pull out an x from the first two terms to get 6x plus 1, and in the second grouping, I'll pull out a 6 to get 6x plus 1. Now you can see that I have a common binomial, so I'll pull out 6x plus 1, and that will get multiplied to x plus 6, the coefficients of those polynomials. And remember, multiplication is commutative, so I could also write this as x plus 6 times 6x plus 1. Either is correct since they are equivalent. And number 16, I'm actually going to start by pulling out a negative 1. So if I pull out a negative 1, or a negative, I'll get 6a squared plus 25a plus 25. So now I have positive numbers to work with. I just have to remember that I pulled that negative out at the start. So that will get put back into my final answer, or multiplied back in, since it's a negative 1. My a value is 6, my b value is 25, and my c value is also 25. So a times c equals 6 times 25, which is 150. So splitting up 150, I'll have 1, 150, 2, and 75, 3, and 50, 5, and 30, 6, and 25, and then lastly 10 and 15. The two factors that add to give me 25 are 10 and 15. So I'm going to rewrite the polynomial, dropping the negative currently, as 6a squared plus 10a plus 15a plus 25. Grouping my last two terms and my first two terms together, I'll now pull out the GCF of each grouping. So the GCF in the first one is 2a, so that'll be times 3a plus 5. And then in the second grouping, I'll pull out a 5, and that'll be 3a plus 5. Factoring out the 3a plus 5, I'll get 2a plus 5 times 3a plus 5. However, that's not my final solution because remember, I pulled out a negative at the start. So I have to multiply by that negative 1 at the end. So my final solution is negative, or the opposite, of 2a plus 5 times 3a plus 5. And if you have trouble keeping track of the negative, keep it in the problem the entire time. Put a negative with parentheses and a negative with parentheses. That way you don't forget to add it back in at the end. In number 17, a is equal to 6, b is 5, and negative 6 represents c. A times c, 6 times negative 6, which is negative 36. The factors of negative 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. Which two will add to give me a positive 5, but multiply to give me a negative 36, that's going to be negative 4 and positive 9, since those add to give me a positive 5. So I'll have 6n squared plus negative 4n plus 9n minus 6, or plus a negative 6, however you feel most comfortable writing it. And see that 5n is indeed negative 4n plus 9n. Grouping my first two terms and my last two terms together, I'm now going to pull out a GCF from each. 2n will get pulled out of my first term, so that'll be 3n plus negative 2 or minus 2. And then 3 will get pulled out of my second terms, so that's 3n plus negative 2 or minus 2. Now that I have a common binomial in each, I'll factor that out. So I'll have 2n plus 3 times 3n minus 2. That's my solution in number 17. And lastly, on this worksheet, number 18. In number 18, I have a greatest common factor between each of the terms. So I'm going to pull out a 4 at the start. So 4 times 4b squared is 16b squared. 4 times 15b is 60b. And 4 times 25 is 100. So now my a is 4, my b is 15, and my c is negative 25. A times c equals 4 times negative 25, which is negative 100. My factors of 100 are 1 and 100, 2 and 50, 4 and 25, 5 and 20, and then 10 and 10. So which two of those multiply to give negative 100 and add to give a positive 15. That's going to be negative 5 and 20. So I'll rewrite this 4b squared plus 15b minus 25 as 4b squared minus 5b plus 20b minus 25. However, note that I dropped my 4, so I need to add that back in to my final answer. Since 4 is multiplied to that polynomial, 4 will be multiplied to the factor of that polynomial. So splitting up my first two terms and my last two terms, I'm going to factor out the GCF. I'll factor out b to get 4b minus 5, and then I'll factor out 5 to get 4b minus 5. So I'll have b plus 5 times 4b minus 5. And if you want to double check, distribute the b and distribute the 5 to see if you do indeed get 4b squared minus 5b plus 20b minus 25. So now that that polynomial is factored, I'm going to multiply it by 4 to get my final solution. 4 times b plus 5 times 4b minus 5. That's my final answer on this worksheet. If you have any questions, leave a comment below. And as always, don't forget to subscribe to my channel and like this video. All likes and subscriptions are greatly appreciated and encourage me to come out with more videos for you. So go ahead and do that now if you haven't already.